Hey folks, Mr. Dell here. We are looking at how to exploring how to find the area of a regular polygon. The example I'm going to use is a decagon, but the process is very similar on any of the polygons. Well, of course, just different values when it comes to the number of sides, and the angle measurements that we're going to be finding and such. So this is a problem from, I'm taking this from CPM's Math 2, Integrated Math 2, and this is section 8.2.2, specifically number 8-50. So it says, what is the area of a regular decagon if the length of each side is 20 units? Remember, a decagon is a 10-sided polygon, right? That's what a decagon is. Okay, so that's important. We got to know how many sides, 10 sides. And regular just means that all the sides are equal, right? And it says that each side is 20 units. Now, you don't actually have to draw the polygon to do this. I have it here just as a reference so we can see this when I'm showing you the process, but you really don't have to. As long as you know how many sides, the process is the same, right? So the process is really you determine this. You just if you have the center of any polygon and you draw from the center um, all of these lengths from the center to each vertex, you're going to draw all of these triangles, right? So what a regular polygon is made up of is many isosceles triangles, right? Isosceles meaning that each of these sides are equal, right? Those would be equal. We also know that these sides on a decagon or any regular polygon are also equal, right? Because they're irregular, so that means they're all equal. So really, all I got to know is that there's going to be 10 because there's 10 sides. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 triangles, right? So if it was a hexagon, there'd be 6 triangles. If it was a pentagon, there'd be 5 triangles. So depending upon how many sides there are, determines how many triangles there are. So over here, I'm going to just draw. All I need to do then, I don't need to have the polygon drawn. I can just draw one of those triangles. And then if I can find the area, so my goal is to find the area of one of the triangles. And then if I can find that area of one of the triangles, I'm going to multiply that by 10 because there's 10 of them. And remember, area of a uh, triangle is always its base times the height, and that's split in half divided by 2, or 1/2 base times height. Okay, so what do I know about this triangle? All I know right now is I know that the base here, because of the side of the decagon is 20, so I know that to be 20. What I can also determine is I can figure out that length, that angle, and that'll help me because the goal is I have its base then, so the 20 is the base. So 20 is my base, so that's good to know. That's going to be part of my formula for finding the area. But now I've got to find its height. Remember, so if I draw in this height of this triangle, what I just did is I now have this 90-degree angle, this right triangle. So I want to use right triangle trig to determine my height, my h. Because if I cut that height down, that also then splits the base here into half. So that's 10 and that's 10. So I know I've got a side of 10. So if I can determine these angles, then I could use right triangle trig to figure out that height. So how do you find that angle? Well, with any regular polygon, we use the formula n minus 2 times 180 divided by n. What does that equal? That equals the measure. So that formula is the measure of the interior angle. Let me write so you can read that. Angle of the polygon, right? Of a regular polygon. So my n in this case is number of sides. N represents the number of sides. And I know it to be 10. So I'll use 10. So I have 10 minus 2 times 180, all divided by 10. So that gives me, let's see, 180. So that's 18. That's actually, okay, let me do the math here. So when I do that math, I get 144. So the angle of one of these interior, so this whole angle here is 144 degrees. Oops, 144 degrees, right? And if that's 144, when I made my my isosceles triangles, I cut that angle in half. So that says over here then that this angle measurement is 72. It's half of the 144. And then I can also determine this angle up here. My height there. This angle right there, then, if that's 72 and that's 90, right? So 72 plus 18 is another 90 degrees. So you have a total 180 in that triangle. So that's 18. So what right triangle trig do I want to use? I need to set up something where I have a ratio to find my h. Remember, right triangle trig, you have tangents, you have cosine, sine. So that's a whole nother lesson. Review your right triangle trig. But in this case, I'm going to use the tangent, the tangent of 72 degrees, because tangent is always opposite. Well, in this case, opposite of the 72 would be my h over adjacent, which would be 10. So now I have a ratio, h over 10, which gives me an opportunity to solve for h. So h is going to equal 10 times tangent of 72 degrees. So again, bring out your calculator. Need a scientific calculator for this. So we got to do the tangent of 72, then times 10. So we get approximately, I'm going to use an approximate symbol here because I'm going to round, approximately 30.8 or 30 I'll say 30.78. Get a little bit more significant digits there, 30.78. So that's my height. All right, so we're good. So we've got now we have the base is 20, the height is 30. So now I can plug it into my formula here. So the area of one triangle is 30, the height times the base, all divided by 2. And that should give me approximately, again, this is approximately, so my area is going to be, for the one triangle, is going to be approximately 307.8. And there's 10 of them. So to find the area of the decagon, so the area of the decagon is going to equal 10 of those. So it would be 3,700 or 3,078 and units. I don't know my units, so I'll just write units squared. So there is the area of the decagon. And that process can be used on any polygon, whether it's 10, 8, you just got to go through the same process each time. It'll give you different numbers, different angles, but that's how it's done. All right. There you go.